Question 1. Given the circumstances, Maria, a senior wind turbine HVACR technician, is assigned to troubleshoot a nacelle cooling issue where the VFD variable frequency drive for the cooling fan is intermittently shutting down. The ambient nacelle temperature exceeds safe limits intermittently, but diagnostics reveal that the compressor is functioning normally. The turbine is operating under heavy load during these events. What is the most likely root cause of the issue? A. Faulty compressor pressure switch preventing cooling cycle initiation. B. Contaminated refrigerant affecting heat absorption in the evaporator. C. Undersized fan motor for the heat rejection requirements during peak load. D. Loose electrical terminal on the high-pressure switch circuit. Answer. Correct answer, C. Undersized fan motor for the heat rejection requirements during peak load. Explanation. When nacelle cooling fails intermittently under high turbine load, a common root cause is inadequate heat rejection, often due to fan motor capacity being undersized or not ramping up with the VFD. The compressor running normally and no pressure switch tripping suggests mechanical components are fine. According to ASHRAE standards and ANSI 61400 turbine cooling guidelines, nacelle cooling systems must be designed to dissipate heat loads that vary with turbine output. Undersizing results in heat buildup, triggering temperature-based shutdowns. Electrical faults or refrigerant issues would show broader system failures, not just under high load. Question 2. Through careful analysis of system recovery procedures, which of the following best describes the proper method for recovering refrigerant from a wind turbine's HVAC system located inside the nacelle, considering altitude, vibration, and accessibility constraints? A. Use passive recovery method with gravity-assisted drainage and filter dryer installed on the low-pressure side. B. Use standard HVAC recovery machine positioned at ground level with an extended suction hose. C. Employ portable vibration-resistant active recovery unit rated for high-altitude operations, placed inside the nacelle. D. Vent refrigerant slowly through the service ports into sealed container and transport it for reclamation. Answer. Correct answer. C. Employ a portable vibration-resistant active recovery unit rated for high-altitude operations, placed inside the nacelle. Explanation. EPA regulations under Section 608 of the Clean Air Act mandate proper refrigerant recovery to prevent atmospheric release. In a wind turbine environment, passive methods are unreliable due to vertical elevation and ambient conditions. Active recovery with vibration-resistant, high-altitude rated equipment ensures effective performance inside the nacelle. Using long suction hoses, as in option B, causes pressure loss and inefficiency. Venting is illegal, option D. Option C aligns with EPA guidelines, manufacturer best practices, and OSHA confined space requirements for turbine nacelles. Question 3. While examining the electrical schematic of a hybrid HVACR blade dicing system, you observe that the blade surface temperature sensor has been bypassed using a jumper wire. Which of the following best describes the implications of this bypass? A. The system will run continuously regardless of blade conditions, increasing energy waste and equipment wear. B. The dicing system will no longer activate, causing excessive ice accumulation. C. The system will only function when ambient temperature drops below freezing. D. The system will enter a locked-out state due to detected sensor faults. Answer. Correct answer, A. The system will run continuously regardless of blade conditions, increasing energy waste and equipment wear. Explanation. Bypassing. A sensor typically removes feedback logic. In this case, the blade surface temperature sensor is critical for enabling dicing only when needed. According to ANSI 6140024 and NFPA 70, such systems rely on sensor input to cycle on-off appropriately. A bypassed simulates a constant condition, often interpreted as Weissing present, leading to continuous operation. This wastes energy and prematurely wears components. The system won't lock out unless fault logic is programmed to detect the bypass, which is uncommon. Question 4. From a practical standpoint, what is the primary consideration when applying lockout-LOTO procedures during maintenance of a cooling system inside the turbine tower base? A. Only the compressor disconnect needs to be locked out, since it's the primary energy source. B. LOTO must include all sources of energy, including electrical, hydraulic, and mechanical movement. C. It is acceptable to post a warning sign in lieu of a physical lock if the technician is within view. D. LOTO is not required if the system is shut off using the local thermostat. Answer. Correct answer. B. LOTO must include all sources of energy, including electrical, hydraulic, and mechanical movement. Explanation. Per OSHA 29 CFR 1910.147, all energy sources must be isolated and locked during maintenance. Wind turbines often involve multiple energy sources beyond just electricity, such as hydraulic actuators or backup mechanical systems. Failing to isolate these lead to unexpected energization and severe injury. Warning signs. Option C. Do not meet LOTO standards. Shutting off via thermostat. Option D. Does not physically disconnect the source. Only option B complies with multi-energy LOTO standards required for wind turbine environments. Question 5. In a modern context of optimizing nacelle cooling efficiency, which system adjustment would most effectively improve thermal transfer when subcooling is consistently too high? A. Decrease compressor cycling frequency. B. Replace the expansion valve with a larger orifice model. C. Just the airflow rate across the condenser coil. D. Lower the refrigerant charge in the system. Answer. Correct answer. C. Adjust the airflow rate across the condenser coil. Explanation. Excessive subcooling indicates the refrigerant is staying in the condenser too long or too efficiently, rejecting heat, which can lead to poor evaporator performance. Increasing airflow over the condenser coil can reduce subcooling by reducing refrigerant dwell time and stabilizing pressure. ASHRAE guidelines support airflow management for efficient heat exchange, lowering refrigerant charge risks undercharging. D. While changing the expansion valve. B. Affects evaporator behavior. Compressor cycling. A. Doesn't directly impact subcooling unless it causes short cycling. Question 6. To illustrate this point, Alex is assigned to perform preventative maintenance on the HVACR unit serving the tower climate control system. During inspection, Alex finds a fine oil sheen on the base of the evaporator coil tray. Pressures are within normal range and no alarms are triggered. What is the most appropriate next step? A. Top off the refrigerant charge to account for minor loss. B. Pressure test the evaporator coil to confirm a leak. C. Replace the evaporator coil immediately. D. Clean the tray and document for future monitoring. Answer. Correct answer. B. Pressure test the evaporator coil to confirm a leak. Explanation. Oil around the evaporator often indicates a low refrigerant leak, as refrigerant carries oil from the compressor. Even if system pressure is normal, EPA Section 608 requires suspected leaks to be verified and documented. Topping off A is illegal without leak confirmation. Cleaning without testing. D. May delay critical repairs. Coil replacement. C. Is premature. A nitrogen pressure test or electronic leak detector should be used per HVACR service protocols for leak confirmation. Question 7. In contrast to traditional residential system, HVACR systems in wind turbine towers must consider which unique thermal dynamic during seasonal shifts. A. Negative pressure drawing humid air into the nacelle from the rotor hub. B. Rapid temperature stratification causing compressor cycling from top to bottom. C. Thermal siphoning from base to nacelle during night cooling phases. D. Air velocity differences from the rotor inducing airflow turbulence in ducts. Answer. Correct answer. B. Rapid temperature stratification causing compressor cycling from top to bottom. Explanation. Wind turbine towers experience vertical temperature gradients due to solar gain, mechanical operation, and sealed structures. This leads to stratification, especially in warm months. The HVACR system must manage upper versus low climate zones to prevent false cycling of compressors. Stratification is a documented challenge in IC 6400 Tower Climate Management Guides. The other options reflect partial phenomena but are less critical than stratification for system design and performance. Question 8. By evaluating the performance of a blade dicing system using glycol-based fluid, which of the following indicators would suggest a failing circulation pump? A. Blade surface remains below freezing despite system activation. B. Pressure on the high side of the loop rises abnormally. C. Fluid temperature in the reservoir exceeds 9 Tide. D. Blades appear wet but ambient air is dry. Answer. Correct answer. A. Blade surface remains below freezing despite system activation. Explanation: the circulation pump moves heated glycol through the blades. If the blades remain cold despite heating activation, it indicates that heat isn't reaching the surface, pointing to pump failure or blockage. Pressure buildup B might occur later, and reservoir temperature C could be due to other causes. Wet blades in dry air D may indicate condensate, but not pump failure. Like 6140024 requires active thermal blade management, and failing pumps compromise performance and increase icing risk. Question 9. The most significant aspect of interpreting a pressure temperature chart during subcooling diagnosis is A. Measuring suction pressure at the outlet of the evaporator coil. B. Comparing ambient temperature with refrigerant saturation pressure. C. Matching condenser pressure with the corresponding saturation temperature. D. Observing compressor discharge pressure under no load. Answer. Correct answer C. Matching condenser pressure with the corresponding saturation temperature. Explanation: to calculate subcooling, you subtract the actual liquid line temperature from the saturation temperature derived from pressure. Thus, identifying the correct saturation temperature from the condenser pressure is essential. PT charts help correlate pressure to saturation temp based on the specific refrigerant. Suction pressure is used for superheat. Subcooling, compressor discharge pressure is irrelevant unless checking for overall system pressure issues. Question 10. Under the assumption that an HVACR technician is tasked with adjusting system performance on a wind turbine operating in extreme cold, which refrigerant property becomes most critical? A. Molecular weight to ensure safety during leaks. B. Boiling point at sub-zero ambient temperatures. C. Specific heat capacity of the oil used. D. Ozone depletion potential to prevent long-term damage. Answer. Correct answer B. Boiling point at sub-zero ambient temperatures. Explanation: wind turbines in cold climates require refrigerants that remain operational well below freezing. The boiling point determines whether the refrigerant can evaporate and absorb heat effectively. If the boiling point is too high, system performance drops or fails entirely. While op and safety are important, DA performance under cold is directly tied to thermodyne properties, specifically boiling point and vapor pressure behavior. This is consistent with ASHRAE refrigerant selection standards for cold climate systems. Question 11. Taking into account the influence of altitude on HVACR system performance in wind turbines, which issue is most likely to occur when a standard refrigerant charge is applied at a high-altitude installation without correction? A. Overheating of the compressor due to higher vapor density. B. Subcooling falls outside acceptable range due to increased condenser pressure. C. Reduced refrigerant mass flow, leading to poor evaporator performance. D. Superheat values will drop, triggering low-pressure cutout alarms. Answer. Correct answer C. Reduced refrigerant mass flow, leading to poor evaporator performance. Explanation: at high altitudes, atmospheric pressure drops, reducing the refrigerant mass flow and affecting heat transfer, especially in the evaporator. This leads to insufficient cooling and system inefficiency. ASHRAE and HEPA guidance both recommend adjusting refrigerant charge or using altitude-corrected system design for turbines above 3,000 feet. Higher elevation doesn't increase condenser pressure B, and lower air density, not higher vapor density A, is the concern. Question 12. Demonstrated by safety violations reported in turbine tower retrofits, which of the following actions by technician Carlos during a leak repair violates both OSHA and EPA regulations? A. Using a vacuum pump to evacuate refrigerant directly into the open air. B. Applying nitrogen pressure testing with a soap bubble leak test. C. Wearing PPE including gloves, goggles, and F-rated clothing. D. Using a reclaimed cylinder rated for high pressure refrigerants. Answer. Correct answer A. Using a vacuum pump to evacuate refrigerant directly into the open air. Explanation: per EPA 40 CFR Part 82, intentional venting of refrigerant is illegal and environmentally damaging. Using a vacuum pump to evacuate refrigerant to atmosphere violates this rule. OSHA also prohibits working with pressurized refrigerants without containment protocols. Options B, C, and D are standard compliant practices, while A carries civil penalties and violates EPA recovery standards. Question 13. With respect to the airflow requirements for nacelle HVACR units, what is the most likely consequence of insufficient return air duct insulation in cold weather conditions? A. Condensation forming inside the control panel leading to system shorting. B. Overheating of the evaporator coil due to airflow reversal. C. False low pressure readings due to duct contraction. D. Ice formation in the return duct reducing effective airflow. Answer. Correct answer. D. Ice formation in the return duct reducing effective airflow. Explanation. In cold environments, uninsulated return air ducts can allow humid air to condense and freeze inside the ducting, especially when pulling air from warm internal zones. This results in reduced airflow and system inefficiency. ASHRAE insulation standards and IC 61400 turbine climate control guidelines recommend insulation on return paths to prevent thermal bridging and condensation. Other options are either less likely or don't align with airflow physics. Question 14. During the process of routine maintenance, technician Olivia notices intermittent power loss to the HVAC condenser fan in the nacelle. She suspects a control circuit issue. Which diagnostic step should she perform first? A. Check resistance across the fan motor windings. B. Review the HVAC schematic and trace the low voltage signal path. C. Replace the fan contactor to rule out mechanical failure. D. Bypass the temperature sensor to force fan operation. Answer. Correct answer. B. Review the HVAC schematic and trace the low voltage signal path. Explanation. Intermittent power issues often stem from faulty control signals or weak connections in the low voltage circuit. Tracing the signal path using the schematic ensures a structured approach per NFPA 70 and industry standard troubleshooting workflows. Directly replacing components C or bypassing safety controls D is discouraged with diagnosis. Measuring resistance A is useful but secondary unless motor failure is suspected. Question 15. In light of recent developments, wind turbine systems increasingly use refrigerants with legitimately lower warming potential. What is the key operational consideration when switching from R400 TINA to a dual alternative like R32 in the same equipment? A. Increased oil lubrication demand and higher thermal conductivity. B. R32 is compatible with all system seals used in R400 TINA units. C. The refrigerant charge must be increased by 20% to maintain pressure. D. R32 is flammable, requiring enhanced leak detection and ventilation. Answer. Correct answer D. R32 is flammable, requiring enhanced leak detection and ventilation. Explanation. R32 has a debut in R400 TINA, but is classified as our mildly flammable. Safety standards like ASHRAE 15 and all 60335-240 require flame-proof components, leak sensors, and ventilation modifications. It's not universally seal compatible. B. And charge levels. C. Very based. System design not always increased. All compatibility and conductivity may differ but aren't the primary operational concern. Question 16. From a historical standpoint, why is superheat measurement critical in determining the evaporator coil's performance in wind turbine HVACR systems? A. It helps verify that the compressor is receiving pure liquid refrigerant. B. It ensures the expansion valve is supplying saturated vapor to the coil. C. It confirms that refrigerant is fully evaporating before reaching the compressor. D. It prevents short cycling of the condenser fan motor. Answer. Correct answer. C. It confirms that refrigerant is fully evaporating before reaching the compressor. Explanation. Superheat is the temperature of vapor above its saturation point. At a given pressure, measuring it ensures all liquid refrigerant has evaporated, preventing liquid slugging at the compressor inlet. Major cause of damage. ASHRAE and EPA training stress its importance in system tuning and diagnostics. Option A is the opposite. Compressors must not receive liquid. Options B and D are either incorrect or unrelated. Question 17. Examining the consequences of poor maintenance planning, technician Nathan fails to replace a clogged air filter inside the wind turbine's base HVAC unit. After 48 hours, the compressor trips on high-pressure cutout. What is the most likely explanation? A. Dirty filters increase refrigerant charge pressure causing compressor surge. B. Reduced airflow across the evaporator increases heat transfer rate. C. Restricted airflow causes inadequate cooling and raises condenser pressure. D. Lack of air exchange triggers control lockout via humidity override. Answer. Correct answer. C. Restricted airflow causes inadequate cooling and raises condenser pressure. Explanation. A clogged air filter restricts airflow across the evaporator, reducing heat absorption. This causes higher pressure in the condenser as the system can't offload heat efficiently. High-pressure trips are a common result. ASHRAE maintenance protocols and manufacturer preventive maintenance plans recommend filter changes every 250-500 hours. Options A and B misrepresent HVAC thermodynamics. Option D is unlikely without humidity sensing control circuit. Question 18. Across different scenarios, multimeters are used extensively during HVACR diagnostic work. Which of the following best describes the correct use of a multimeter when checking for compressor winding failure? A. Measure line voltage while the system is off to avoid arc flash. B. Check resistance across compressor terminals to detect shorts or opens. C. Set the meter to amperage mode and clamp all three wires simultaneously. D. Use continuity mode across the capacitor terminals to check winding impedance. Answer. Correct answer. B. Check resistance across compressor terminals to detect shorts or opens. Explanation. Resistance checks across compressor windings help detect open or short circuits in the motor. This is standard practice in diagnosing HVACR motors per NFPA 7-tire manufacturer service guides. Amp mode C requires live current and clamping individual wires. Continuity mode across capacitors D can damage the meter and doesn't measure impedance. Line voltage checks they are done live, not during system shutdown. Question 19. The prevailing attitude toward dehumidification inside wind turbine towers is shaped by which of the following concerns? A. Internal condensation can lead to galvanic corrosion of control boards and terminals. B. Too much moisture causes refrigerant migration to the evaporator coil. C. Humid air increases expansion valve sensitivity. D. Moisture inside the tower improves natural convective airflow. Answer. Correct answer A. Internal condensation can lead to galvanic corrosion of control boards and terminals. Explanation. Turbine towers are semi-sealed spaces where humidity control is vital. Moist air condenses on metal surfaces including PCB traces and wire terminals, leading to galvanic corrosion. This degrades signal transmission and causes system failure. ASHRAE and turbine OEM guidelines require dehumidification systems or humidity monitoring HVAC units. Other options are inaccurate or not root causes of tower dehumidification concerns. Question 20. The effectiveness of passive blade de-icing systems is most dependent on which design factor? A. Blade orientation relative to wind direction. B. Solar absorption properties of blade material. C. Moisture content in the ambient air. D. Your system engagement frequency. Answer. Correct answer. B. Solar absorption properties of blade material. Explanation. Passive de-icing systems rely on solar radiation to heat blade surfaces and melt ice. Material selection, including surface albedo and emissivity, directly affects heat retention. According to IC 6140024, blade coatings can enhance solar absorption and reduce ice adhesion, wind direction, yaw frequency, or humidity. A. C. Influence icing, but not the effectiveness of passive de-icing mechanisms. Question 21. The correlation between refrigerant glide and system performance becomes critical when using zeotropic blends like R407 in wind turbine applications. Which issue is most likely to occur if the technician misinterprets the midpoint temperature instead of using appropriate dew bubble points during charging? A. Evaporator performance will increase beyond design limits. B. The system may be undercharged, leading to low suction pressure. C. Overcharging causes high superheat and coil icing. D. Condenser flooding occurs due to vapor phase charge imbalance. Answer. Correct answer. B. The system may be undercharged, leading to low suction pressure. Explanation. Zeotropic blends like R407 CAV A temperature glide requiring bubble point for charging liquid and dew point for superheat evaluation. Using midpoint temps results in undercharging, reducing suction pressure and cooling efficiency. ASHRAE recommends using manufacturer-specific charts when working with glide refrigerants. Overcharging or icing (CD) is more likely with saturated refrigerants like R400 TINA when mismanaged. Question 22. According to recent studies, technician Diana is performing maintenance on a wind turbine HVAC unit located in an arid region. The internal components are accumulating a fine dust layer, which measure will most effectively preserve coil efficiency and system airflow. A. Install an additional return duct damper to reduce infiltration. B. Increase refrigerant charge to overcome airflow losses. C. Perform regular core cleaning using non-corrosive solvents and soft brushes. D. Operate the unit on maximum airflow mode at all times. Answer. Correct answer. C. Perform regular core cleaning using non-corrosive solvents and soft brushes. Explanation. Dust buildup on cores reduces heat transfer, impairs airflow, and increases system pressure. Regular cleaning with non-corrosive solvents preserves core fins and maintains performance. ASHRAE recommends monthly inspections in dusty conditions. Increasing charge. B. Doesn't address root cause. Operating at max airflow. D. Increases wear. Dampers. A. Reduce flow but not filtration. Question 23. From a practical standpoint, what is the most likely consequence of failing to integrate the HVACR tower climate control system with the wind turbine's main SCADA control platform? A. The tower climate system will operate continuously, increasing humidity. B. HVAC alarms and failure data will not be logged or reported remotely. C. Generator winding temperatures will fall below operating thresholds. D. The yaw system will fail due to temperature drift in the base cabinet. Answer. Correct answer. B. HVAC alarms and failure data will not be logged or reported remotely. Explanation. Without SCADA integration, alarms and performance data from the HVAC unit are invisible to remote operators. This impairs condition monitoring and delay responses to failures. IC 6140025 specifies data communication standards in wind turbines, including integration of auxiliary systems like HVAC. Continuous operation A would only happen with mechanical failure. Generator and yaw systems C, D are separately monitored. Question 24. To determine whether scroll compressor in a wind turbine's cooling unit is functioning properly after capacitor replacement, technician Felix measures 0 ohms between the run and common terminals. What does this result most likely indicate? A. Internal short in the compressor windings. B. Properly functioning compressor circuit. C. Open overload protector that has not reset. D. High resistance due to failing run capacitor. Answer. Correct answer A. Internal short in the compressor windings. Explanation. 0 ohms between run and common indicates shorted windings, which means the insulation has failed. Normally, resistance should be measurable, usually a few ohms. NFPA 70 and manufacturer diagnostics outline this test. A functioning compressor B would not show 0 ohms. An open protector C shows all, not 0. A failing capacitor D doesn't directly affect winding resistance. Question 25. Focusing specifically on environmental compliance, what must an HVACR technician working on a wind turbine cooling system do immediately after detecting a suspected refrigerant leak? A. Report it to the local EPA regional authority. B. Isolate and repair the system within 30 days to remain compliant. C. Add refrigerant to balance the system until full repair is scheduled. D. Vent refrigerant if the system is in a remote location. Answer. Correct answer. B. Isolate and repair the system within 30 days to remain compliant. Explanation. EPA Section 608 requires technicians to repair leaks within 30 days of detection for systems with more than 50 pounds of refrigerant. Many turbine systems qualify. Venting D is illegal. Adding refrigerant C without repair violates containment rules. Reporting to EPA A is only required if leak rates exceed thresholds, 30% annually for comfort cooling. Question 26. In the absence of proper airflow balancing in a wind turbine tower, which condition is most likely to develop during sustained cold weather operation? A. Condenser coil overheating and high pressure faults. B. Negative pressure at the nacelle causing HVAC short cycling. C. Warm air stratification at the base leading to sensor drift. D. Cold air pooling at the base, reducing occupant comfort and component lifespan. Answer. Correct answer. D. Cold air pooling at the base, reducing occupant comfort and component lifespan. Explanation. Without airflow balancing, cold, dense air settles at the bottom of the tower while warmer air rises. This creates discomfort for technicians, affects electronics, and may freeze hydraulic components. ASHRAE recommends vertical air mixing in tall structures to avoid stratification. Overheating coils A or short cycling B would result from other faults. Warm air doesn't pool at the base C. Question 27. The underlying principle of proper component testing in turbine HVACR systems is to isolate faults without disrupting live systems. When testing, a faulty contactor suspected of having welded contacts. What is the safest and most accurate test method? A. Check voltage across the contactor coil during operation. B. Use a megameter to test insulation resistance across terminals. C. Measure resistance across the line and load terminals when de-energized. D. Inspect for pitting or arc marks under live conditions. Answer. Correct answer. C. Measure resistance across the line and load terminals when de-energized. Explanation. Testing contactors for welded contacts is best done de-energized by checking continuity across the contacts. If resistance is low with the coil de-energized, contacts are welded shut. This complies with NFPA 7 tie-arc flash safety protocols using a megameter. B. Checks insulation, not contact condition. Live inspection. D. Dangerous and non-compliant. Question 20. Historically speaking, why is subcooling a more accurate indicator of proper charge than sight glass inspection in turbine condenser systems? A. Subcooling accounts for outdoor humidity and wind speed. B. It measures the difference between ambient and evaporator temp. C. It evaluates actual refrigerant conditions regardless of visual clarity. D. It prevents vapor lock in the liquid line caused by uneven airflow. Answer. Correct answer. C. It evaluates actual refrigerant conditions regardless of visual clarity. Explanation. Sight glasses can appear full even if undercharged, especially with blends or turbulent flow. Subcooling, the difference between condenser saturation temp and liquid line temp, gives accurate feedback on charge. ASHRAE and EPA recommend subcooling over visual indicators. Wind, humidity, and airflow A. B. D. Don't affect refrigerant condition measurement. Question 29. The foundation of reliable wind turbine blade dicing depends on what operational parameters are being accurately controlled. A. Blade pitch angle during icing conditions. B. Surface temperature maintained above freezing point. C. Your rate during blade heating phase. D. Rotor speed synchronized with tower temperature. Answer. Correct answer. B. Surface temperature maintained above freezing point. Explanation. Dicing systems, both active and passive, must keep blade surface temp above freezing to prevent ice adhesion. Like 614024 mandates blade heating systems maintain this temp via resistive heating, glycol systems or coatings. Pitch angle A affects aerodynamics, not dicing. Yaw and rotor speed C. D. Don't directly impact surface freezing. Question 30. In response to a recent series of HVACR tower unit failures, a root cause analysis reveals repeated compressor trips due to liquid slugging. What system defect is most likely responsible? A. Suction line is too short for the vertical run. B. Thermostatic expansion valve is oversized for the system load. C. Liquid line filter dryer is oversaturated with moisture. D. Return air temperature sensor is out of calibration. Answer. Correct answer. B. Thermostatic expansion valve is oversized for the system load. Explanation. An oversized TXV delivers too much liquid refrigerant to the evaporator, which may not fully vaporize. This causes liquid slugging at the compressor, leading to mechanical damage. ASHRAE and EPA training emphasize correct TXV sizing for altitude and load. Short suction lines say reduce oil return, not slugging. Moisture-saturated dryers C. Cause restrictions but not flooding. Return air sensors D. Don't affect liquid flow.